day, integrated topic students. Today we're going to be looking further for inequalities. So you guys need to bring in your homework, the pencil, calculator, and loose leaf paper for notes. So first thing, we're going to start off with a review of what we did last class, which was solving inequalities with one variable. So for example number 1, we have 3w plus 5 divided by 4, which is greater than or equal to 2w. So the first thing that we should do is to multiply both sides by our denominator, which is 4. Reason why we're doing that 3w plus 5 divided by 4 is division, so we need to do the opposite, which is multiplication. Once we do that, we have 3w plus 5, and it still will be greater than or equal to because we did not multiply by negative. So it'll be greater than or equal to 8w. So now we're going to solve just like we did for equations. That means I want to have my variables on one side equal sign, well in this case the inequality, and the other side should just be my constant. So in this case I would actually subtract 3w because I want to put all my w's on one side, which leaves me to 5 greater than or equal to 5w. So if I'm solving for w in this case, I want to divide both sides by 5, and since I'm dividing by a positive number, my sign stays the same. So these 5's will cancel out, giving me 1w, and 5 divided by 5 is 1. So the answer here will be 1 is greater than or equal to w. For the next example, we have the opposite of 4 times a number is more than 12. So the opposite 4 times a number is more than 12. When you see a word problem, break it up. So the first part is the opposite of 4. Now the opposite of 4 will be a negative 4 times a number. So we can think of any number, so we can use x. So that means I'm taking that x and I'm multiplying it to my opposite of 4. Is more than. So I have my greater than symbol, and then I have my 12. So when you read it, try to break it up into parts. So if I put this whole thing together, I should have negative 4x greater than 12. So let's go ahead and solve. We want to divide both sides by a negative 4. As a result, since I'm dividing by a negative, my sign, my inequality is going to change. So now I have x is less than negative 3. So I can use any number that's less than negative 3 to satisfy our original situation. So let's see if I can test it out. If I plugged in a 0, is 0 less than negative 3? Try to fool you there. It's not less than negative 3. So what's next less than negative 3 is a negative 4. So if I plugged in a negative 4 for this x, I would get a positive 16. Now is 16 greater than 12 a true statement? Yes, it is. Okay? And I can continue on if I wanted to check again. If I wanted to replace that negative 4 with, say, negative 5. So here I'll get a positive 20. Now is 20 bigger than 12? And it is. It's greater than. So far that's how it will happen. Because if you didn't flip the sign, you will definitely get an error. For example, number 3, 40% of a number is less than or equal to 45. So you're probably saying to yourself, 40%? How am I going to write that? So instead of writing it as 40 with the percent sign, you can actually write it as a decimal, which is 0.40 or 4/100ths or 4/10ths really, because you don't really need the 0. Okay? So 4/10 of a number, say you wanted to use n, this operation of, if you go back to your terminology, the operation terminology sheet that I left on the website, of means multiplication. So that means I'm multiplying that number. So I should have 0.40n is less than or equal to 45. So now we're just going right into solving. So we're dividing both sides by 0.40 or zero point 0.4. Since I'm dividing by a positive number, my sign is going to stay the same. So it'll be n is less than or equal to 112.5. Okay, so any number less than 112.5 will satisfy that inequality. In this example number 5, I didn't have them write down in their notes, but we can definitely be able to look at it visually. I want you to find the error. So we had Anya and Zach, and they're solving this inequality. 1/2 times 10x minus 8 minus 3 times x minus 1, which is greater than or equal to 15. So which one, was it Anya or Zach, that had the correct answer? So hopefully you said Zach had the correct answer. But where was the error? What happened? They both started out with the same equation, but what happened? If you notice in the beginning, they had to distribute 1/2 to everything in that first parenthesis, and they had to distribute a -3 to everything in the second parenthesis. So it looks like she took 1/2 of 10x, that's where that 5x came from, but then 1/2 of 8 she didn't do. She forgot to distribute that 1/2 to everything inside the parenthesis. She didn't only just do it in the first sequence, she also did it in the second sequence. Because that's not supposed to be a -1. In fact, it should be a +3. And that -8 from the beginning right here should have been a -4. So the one that had it correct was Zach, because he distributed everything inside each of the parentheses. Okay? So this shows that yes, you will get an answer when you distribute. You will get an answer, but sometimes you need to check your work. And I see that a lot for all my students. You do the arrows, but then you forget to multiply that second portion. Okay? So that was just basically a reminder. So then we're going into the actual second piece. So we worked on solving with one variable. Now we're actually going to learn how to solve and graph using two variables. So as you notice in my pictures, I have two equations. One is ax plus by equals c, and this is considered standard form. So this is the start of most equations. So through standard form, we can solve for y. And when we solve for y, what we develop is what's called a slope-intercept. Okay, slope-intercept form. So we've seen slope-intercept form over and over and over again. So with the slope-intercept form, my m is going to represent my slope. Remember slope, rise over run, rate of change. And my b is going to represent my y-intercept. Okay, y-intercept is another name for the starting point. Anytime you see something that says initial fee, a starting process fee, that's what they're talking about, your starting point. So we're going to look more so when we have an x and y value. Okay, but we're solving everything exactly the same as we would do it for an equation. So this is something that I would like for you to write down and try to remember these, okay? So now that we're going to be graphing, we're not just going to graph on a number line, we're actually going to graph on a coordinate plane. And when we're graphing a line, when it comes to inequalities, there's two types of lines that we're going to deal with. We're going to deal with a dotted or a dashed line, and we're going to deal with solid lines. So the way that you can tell when to use which line is based on the inequality. So if you have a greater than or just a less than inequality, you're going to use a dashed or a dotted line. If you have greater than equal to or less than or equal to, you're going to use a solid line. Since it's equal to, that means it's including that number. It's including that number that it's less than. It's including that number that it's greater than. So since we're including that number, we want to use a solid line to represent that inclusion. And the second piece that's listed here is the steps on how to graph. So first things first, our equation, or in our case right now, our inequality has to be in that slope-intercept form. So in order for you to graph, the first thing you do, you're graphing your y-intercept on that vertical axis, hence the y-axis. Then you're going to use your slope from that y-intercept to plot your next point. So remember rise over run? So that means your rise, that means you're either going up or down, and your run, you're either going right or left. So the two type of lines, dashed and solid, one's dealing with just greater than or less than, the other one's dealing with the equal to. So before we get into it, I just wanted to show them that the graphs of an equation versus a graph of an inequality is basically the same, okay? When you graph an inequality or a coordinate plane, we're basically splitting that plane into two regions, hence called half planes. So if I were to graph y equals 2, I know that it's never going to cross the x-axis. So I have my point on y equals 2, and it will be a straight line. We'll see if I can draw a straight line. Just through that y-axis. Okay? So it has nothing to do right now with the x-axis at all, because it's telling me that that's what y equals. It equals 2. Whereas the inequality, y is less than 2, that's also going to go through that point of 2 on the y-axis. But this time, it's not going to be a solid line because it's telling me that it's less than 2. So if we refer back, if we have a greater than or less than symbol, we're using what? A dashed line. So in this case, we're using a dashed line to represent the inequality. But what I was trying to prove here is that the way that you graph an equation of a line, or if you're graphing an inequality of a line, you're still doing the same process. Okay? For the next part, we'll notice that the graph of an inequality is the set of all points that are solutions to the inequality. When we did equations, we represented a few solutions, whereas the inequality is going to be a much larger range of solutions. So instead of us plotting each and every single solitary point that's associated with the solutions, we can do what's called the shading method. And I'm going to show you how to do that momentarily. But right now, I want to see what are some of my solutions that deals with the inequality 3x plus 2y less than 12. So if I were to pick a couple numbers, let's say -2, -1, 0, and 1. what I would do to get that y value is just simply plug in these x values in for x and go ahead and solve. So 3 times negative 2 gives me a negative 6. And I will add 6 to both sides. So then I'll have 2y is less than 18. So that means y is going to equal 9. If I do the same thing for the negative 1, so 3 times negative 1 gives me a negative 3. And I'll add 3 to both sides. So that'll give me 15. And I can leave it as 15 halves, or it'll be 7.5. And the last one will be 3 times 0, which is 0. So now I have 2y is less than 12. That means y has to be less than 6. And the last one, 3 times 1, this will give me 3, plus 2y is less than 12. Subtract 3 on both sides. So I got 2y is less than 9. Divide by 2 gives me 9 over 2, or a positive 4.5. So basically what I'm saying, that the point negative 2, 9, I'll write it up here, negative 2, 9, negative 1, 7.5, 0, 6, and 1, oops, comma 4.5, they are some of the solutions for that inequality. But my thing is, we really want all the solutions. This is just a small range of them. And I know by habit, you're going to just want to draw a straight line through all that. But guess what our sign is? Isn't it less than? If it's less than, that means I should be drawing a dashed line. And this barrier, okay, is showing how I'm splitting up my coordinate into 2 ordered pairs. So here's 1 order pair, and there's the second one. Okay? So in order to find some of the solutions, all you have to really do is just plug it into your x and y and see if you get a true statement. So once again, showing you the steps. So steps in graphing inequalities. First, put your inequality in that slope-intercept form. It's going to be y less than or y greater than. It's not necessarily going to be y equals, but that process is still the same. Then you're going to draw either a solid or a dashed line based on the inequality. So if it's a less than or equal to, you're drawing a solid line. If it's greater than, you're drawing a dashed line, okay? Based on what it is. If it's not equal to, it's dashed. If it is equal to, it's solid. Then we're going to test it with that point 0, 0 to figure out which side am I going to shade, okay? Which side has that true statement? And for a hen, greater than, you always shade the top, and less than, you shade the bottom. So let's look at a couple examples. So remember, if I'm going too fast, you can always pause it, okay? So example 1, 5x plus 4y is less than or equal to 12. So first things first, I need to solve this for y. So I would subtract 5x on both sides, and I will get 4y is less than or equal to 12 minus 5x. Remember, you can't combine those. Now I need to divide everything by 4. And since I'm dividing by a positive number, the sign does not change. And you're probably saying to yourself, why is she leaving it as a fraction? Remember, the coefficient or the number that's in front of my x, that is my slope. Remember, slope is rise over run. Rise over run is already set up like a fraction. Okay? They have that factorial bar right there. Okay? So if we're doing that, it's a lot easier, especially with graphing, to keep it as a fraction. Okay? It's a lot easier to do 5 over 4 over 1.25. So now, let's graph. Where do I start? So I will start at my y-intercept. My y-intercept is telling me it's a 3. It's positive 3, so I'm putting a point on positive 3. And from this point, I'm going to look at my slope. And my slope is telling me negative 5/4. So I can go down 5 and then over 4 to make my other point. So now I have my 2 points. I'm ready to draw a line. Am I doing a dashed or a solid? Since it's less than or equal to, I should be doing a solid line. So here we go with the testing. You see that that point 0, 0 is on one side of my boundary line. So this, the line that we drew, that's the boundary line. So my point 0, 0 is on one side of that boundary line. So I'm going to use that point to help me to figure out which side is carrying all the true statements. So instead of me doing each and every single solitary point on each side, which will take me forever, I could just simply test one point. So if I test that one point, that means I'm substituting a 0 for that y, and I'm substituting a 0 for this x. Now, anything times 0 is going to give me 0. So right now, I have 0 is less than or equal to 3. Because this 5/4, be it negative, times 0 is going to give me 0. So what's left is that 3. So now ask ourselves, is 0 less than or equal to 3 a true statement? And the answer to that is yes. Since it is a true statement, this is the part that everyone loved today, I'm going to shade the side that contains that true statement. So my 0, 0 is on that bottom side. I know, right? It's fun. Look at the color. Okay? We can sit here and color all day. But all of this is getting shaded. So that means all these points, oops, all these points that's on this side of the line are going to be true statements. Okay? Each and every one of them are going to be true statements. So if we pick the point, how about negative 1, 1? So that means I will put a negative 1 for my x and a 1 for my y. So if I put a negative 1 for my x and a 1 for my y, 5 times negative 1 gives me a negative 5 plus 4, okay, less than or equal to 12. So negative 5 plus 4 give me a negative 1 less than or equal to 12. Is that a true statement? Yes, it is. Okay. So let's try another one. So we got x less than 4y minus 2, and we're solving this for y. So that means I can add 2 to both sides, And this will give me x plus 2 less than 4y. Divide both sides by 4. So I'm dividing everything by 4. As a result, I'm going to get 1/4 x plus 0.5 is less than y. And you're probably asking, where did the 1 come from? Anytime you see a variable of x or a variable of y, there's always assumed that there's a 1 in front of it. So now let's graph. Where do I start? Oops. So I'm going to start at my y-intercept, which is 0.5, which is between 0 and 1. And from that point, I'm going to go up 1. Now, be careful. If I go from this point and I go up to the number 1, that's not a full step. That's only a half a step. I need to go in between the 1 and the 2 in order to be considered a full step. And then over, whoops, that's ugly line, and then over 4. So am I drawing a solid or a dashed line? Hopefully you said dash. Okay, it's not really a line, but you know what I'm saying. Okay, and it's dash because I just have a less than symbol. So now we need to figure out which way to shade. So we're going to use our handy dandy 0.00, which is right here. So I'm going to put a 0 in for the x and a 0 for the y. So anything times 0 is 0. So I have 0.5 is less than 0. Is 0.5 less than 0 a true statement? No, it's not. So that means we're shading the side. All right, what can I freak you out with now? Shading the side that is away. Oops. Okay, all of this. All this is going to be shaded. Stars galore. Okay, including, I didn't want to cover up my my numbers too, but all this is going to be shaded. Okay, so everything away from that 0.00 is going to be shaded because it came up as a false statement. Okay, 2 more. Now I have y is greater than 2. So this is similar to what we were looking at earlier. So that means my point is on 2. Am I drawing a solid or a dashed line? It's going to be dashed. So now, which side am I going to shade? Remember the little hint that I gave you. If it's greater than, you're going to shave on top. If you don't believe me, let's try it with our test of 0, 0. So 0, 0 is down here. 0 is greater than 2. Is that a true statement? No. So we're going to shade the side. Yeah, the things freak me out. So you're going to shade the side that does not include 0, 0. Okay? Because 0, 0 is below that boundary line, and 0 is not greater than 2. So we shade the side that is away from it because it is not a true statement. Okay? And the last one. X is greater than or equal to -3. So we're not involving the y-axis at all. It's the -3 that's on the x-axis. Am I doing a solid or a dashed line? I should be doing solid because it says it's equal to. So greater than or equal to -3. Which numbers will be greater than? The left side or the right side? Hopefully you said the right side. So all the numbers, all this, okay, all the numbers on this right-hand side is going to satisfy that inequality, okay? I did get a handle on another website just in case you're not quite getting these. Please don't hesitate to contact me. For homework, you're going to complete the inequalities homework number 1, which I'll have on the website. And we're going to try to work all these things out. But I did get a new website that I'm going to add to it. So make sure you look under the rules section and the materials section. Okay, I'm probably going to put it underneath the materials section. It's a new website that I got from the board, so we'll see how that works out for you guys. Okay, so if you need additional help with this, you're not quite getting what I'm talking about, either shoot me an email or come see me during Wildcat Hour or take a look at the other website. Okay, so this was solving inequalities with two variables. And don't forget, when you have greater than or less than, you're going to use a dashed line. When you have equal to, you're going to use a solid line. Okay, and you're solving your equations just like you would. You're solving your inequalities just like you would an equation. So in this case, we want to solve it for y so we can get our inequality line to representation. All right, so I'll talk to you guys